Here I have some code from an earlier video where we made this 3x3 NumPy array with zeros in the top row, ones in the first row, and so on. Let me change it just very slightly. Let me change it to all fours. Hey, I'll say why I wanted to do that in a second. And let's look at this array. Okay, so it's the analog of what we did before. It's constant along the rows. So for example, this row, it's all twos. And so I think the top line is pretty self-explanatory. This makes a 4x4 NumPy array of all zeros. And then this line I think is a little more confusing. So let's break it up. And for example, if I look at ARR brackets, how about 2? So what this is doing, like, let's look at ARR by itself. So here's the 0th row, the first row, the second row. And so this is showing me that row here that I started to highlight. Okay, this row here. And so that's how you can access that second row. If you want to change it, which is what we were doing up here, you could do ARR brackets 2 equals 13. And then if I look at ARR, it gives me this same 4x4 NumPy array, but now we have all 13s in this second row. If you want to do that for, say, the second column instead, it's a little bit harder. You have to say colon, comma 2. And so think of this colon as saying, give me every row, or within every row, I want the second column. And then let's set this equals -4. And then if I look at ARR, it went to the second column and set them all equal to -4. This ARR brackets 2, that works the same way if you have a colon after it. So here they think of this as saying, go to the second row and give me every column. So let's do it with a different row. Let's go to this first row and let's set that equal to 1. And then if I look at this, here we can see that all of these have been set equal to 1. So those are some examples of how you can change a row or a column into a constant number. If you want to access a column, okay, for example, say you want access to this second column, you can do ARR, or let's also save it. Let's call it V, because maybe I'm thinking of it like a vector. And let's say, give me every row, second column. And here is what V looks like. Okay, it's a single column, so it's now a one-dimensional NumPy array instead of this one, which was a two-dimensional NumPy array. If I check what's the shape of it, then I get that its shape is this little length 1 tuple with just a 4 in it, because it's length 4 and it's one-dimensional. So one-dimensional, that's the same as there being just one number in this shape. What if I try to do ARR? Let's go to one that we haven't accessed yet. Let's go to the third row. And let's try to set this equal to 210. So do you have a prediction for what's going to happen here when I try to set this equal to 210? So I think it would be reasonable to expect that it got expanded out. So 210, then another 210, but that's not what happens. It says we get this value error, and it says could not broadcast input array from shape 2, okay, which is the shape of this, into shape 4, okay, which is the shape of this row. So what is that broadcasting about? Well, let me show you an example. So say I do ARR, and then originally, this is my second time trying to make this video. Originally, what I did was ARR equals 1347, but that was a mistake on my part. That just overwrote the old definition of ARR and set it equal to this length 4 list, 1347. So I need some way of telling Python or telling NumPy that I want to change the current values in ARR instead of erase ARR and make this new thing. And so the way I can do that is I can use slicing, and this is just like saying, for everything in ARR, set it equal to 1347. Okay, that didn't give me an error. And so what happened? Like, how did it work? Well, let's look at what ARR is. And so what you should imagine is that these numbers are all going to appear in the array, and they're each going to appear 4 times. And I think there are 2 different ways you can imagine it. Either you could imagine it's going to be a column is 1347, and then every column is that 1347, or vice versa with the rows. And so let's see what it did. So it did the opposite. It made each row equal to 1347. And so why is that? Well, if we look at the shape of the array, and I mean, there's no way to know this in advance. This is just how NumPy is programmed. So what it does is it takes, let's call this, how about W? And let's convert this into a NumPy array. Okay, why did I want to do that? Because I want to call .shape, and if you do .shape on a list, you'll get an error that says list does not have a shape attribute. And so what NumPy does when you try to assign like ARR to be filled in with W, it does what's called broadcasting, and it tries to send all of the values in W into ARR. And the way it works is it works from right to left, and so it matches up this with this. And so this number here, it refers to the columns, and so this is going to match up to the columns. So for example, the 0th thing in W is going to match up with the 0th column. So the 0th thing in W is this 1, and that's going to match up with the 0th column in ARR. And that's just the convention for how broadcasting works in NumPy. So what if I wanted to go back and let's look at this thing from before. So here I was making this 3x3 NumPy array, and let me show you how we can make that using broadcasting. And so maybe I'll show you 2 different ways we can make that. So let's just print it here so we can see what we want to get. So one way is I could say ARR equals 0s, 3 rows, 3 columns. Okay, and then I could say ARR, okay, for everything in it, set that equal to, and let's get 0, 1, 2. And I could do either the original Python range or the NumPy A range. I'll do NumPy A range. And then let's check what ARR looks like after this. And so what did I do wrong? I got this error that says zeros is not defined. Forgot the np.zeros. Okay, good. But I didn't get what I wanted here. Okay, because here I want the rows to be constant, and here the columns are constant. Okay, that's what we were just talking about a minute ago. So one way is I can use what's called the matrix transpose, and you get that using .t. And now I get what I want. Okay, 0s, 1s, 2s. Okay, if you check what's ARR after this, okay, it's still the old definition. And so if you want to actually change ARR, okay, you need to actually set it like this. Okay, then if you check what's ARR, now it's this correct thing that's constant along the rows. Let me show you one last way to make this 3x3 NumPy array that's constant along the rows. And this one I'm also going to use broadcasting. So I'll do ARR equals np.zeros 3x3. Need to make sure the inside is a tuple. So I need to make sure there's 2 sets of parentheses here. And so here I'm going to use broadcasting, and I'm going to use it in a slightly different way. I'm going to say ARR colon, and then let's do np.arange3. So far it looks exactly the same as before, but here I'm going to reshape it so that it's 3 rows and 1 column. And then let's check what ARR looks like. So, I mean, that seems kind of wild. How did it work? Well, let's save this with the name, how about X? And let's look at X. And what's the shape of X? 3 by 1. And what's the shape of ARR? Hey, that's 3 by 3. And so these sets of dimensions, they are also compatible for NumPy broadcasting. And in general, two lists of dimensions are compatible if starting from the right and working your way left, either the two numbers are equal or one of the numbers is equal to 1. So these are compatible. And so what happens is that it gets stretched out along this dimension. So in this case, the 0 gets stretched out along the columns dimension. Okay, this is the rows dimension. This is the columns dimension. So this 0 gets stretched out. So you should imagine that it's like 3 zeros and then 3 ones and then 3 twos. And then that's what's getting added to my array of all zeros. And that's how we get this thing that's constant along the rows. Maybe the last thing I'll do in this video is just show you another way to make this. And if, why did I put the 3 here? Well, that was what was necessary to have it match with this number 3. If I put something like 2 here, I get this error that says there's no way to reshape this thing that's length 3 into something that's size 2 by 1. Okay, these numbers need to multiply to give me however many elements are over here. So in this case, they need to multiply to give me 3. But there's a nice shorthand. So really all I cared about was that there was 1 column in this NumPy array. And so if that's all you care about, then instead of specifying how many rows there should be, you can just put a -1 here. And that's an abbreviation that tells NumPy, put whatever number you need here to have it work out. So in this case, it's going to automatically put a 3 there. Okay, and then if I check what is Z, it's this 3 row by 1 column NumPy array. Okay, and if I check what's the shape, it's not shape -1, 1, it's shape 3, 1. And so that -1 abbreviation, that's often really helpful if you don't want to compute exactly how many different elements there should be. As another example, I have this ARR, and if I do ARR.reshape, and then I just give it -1, so then that tells me there should only be 1 dimension, and it should be whatever length is necessary to hold all 9 of these numbers. Okay, so it automatically puts a 9 in here, and it gives me this length 9 NumPy array.